Hello, my dear. How are you all? Look, class, after completing chapter number 1 successfully, now we are just starting chapter number 2, which is about measurement and experimental techniques. And I ease your load that this will be a sort of revision of all the knowledge which you had already understood in general science with the measurements and the scales and the apparatus used to measure different physical quantities. So let us begin the discussion now. I'm sure these pictures are not new for you because your stationery box must be containing some or all of them for the routine measurement during your classwork. So, the first question, why measurement is needed? You know, without the ability to measure, it would be difficult for a scientist to conduct experiments or to form theories. Not only in measurement, important in science or in chemistry and all the chemical industry, it is also essential and needed in farming, engineering, construction, manufacturing, commerce, and numerous other operations and activities across the globe. So, measurement is the basic tool to study, to compare, and to conclude any observation or any fact during our daily life practices. Now we had already understood that there is a modern metric system which is simply called as metric system, which we use to measure physical quantities, and that unit is called that system is called as, yes, what's that? That's International System of Units, and for shorthand we use this SI. This S stands for system and I stands for the international. So this is International System of Units, which are simply called as SI units. And we have 7 physical quantities. The quantities that we can observe are also placed in this unit system, and they are length, mass, time, electric current, temperature, amount of substance, and luminous intensity. So we have a little bit idea of mostly all of the physical quantities, how they are measured. Now let us have a look on the table in which all these 7 quantities are tabulated, and the units are there and the abbreviations are there. Have you ever worked with them? Yes, you had been calculating the length and the mass and the time and the speeds and volumes and areas and one more thing, yeah, force. So all of these were the interaction and application of the SI system. Now today we will just cover specifically the physical quantity mass. Now, you know what is mass? First, we highlighted the SI unit for the measurement of mass is the kg. So you need to remember it. Okay. So mass is the measure of the amount of matter in an object. So perhaps this is the definition of mass. So mass is usually measured in grams or kilograms in daily activities. And the mass we measure is the quantity of matter that remains constant, and that amount is regardless of the both of its location in the universe and the gravitational force applied to it. So why this is written here? Because the amount of matter remains constant in the whole universe. So this is just the revision of the difference between mass and weight. So mass is something which is just the measurement of the amount of matter in any object. So we see the different units of mass, but we have to remember that the SI unit in which we measure mass is in the kilograms. So here it is. And the other smaller and larger units given, and I have also given you something to help you understand about the conversions between the larger and smaller systems. So as this is the metric system, it is raised to the power of 10. So this is the main conversional tool between the smaller and larger units. The next is when we come to measure mass. The previous days we had been measuring the mass using the beam balance. Yes, the top picture. This is the picture of a beam balance. Why it is called as a beam balance? Maybe due to this beam, the presence of this beam. Okay, so it measured mass successfully, but these days in which we need to measure mass very smaller quantities, so that's why we have made this electronic balance, this one which runs on electricity. So that's why it is called as electronic balance. And this balance has got one advantage, that we can accurately measure the mass of any object up to the accuracy of 0.01 gram mass, up to 2 decimal places. That's why it is used for precise and fast weighing. So this is how we can measure mass. Just we need to put the subject on the pen, and the digits tell us the accurately measured mass. So this is the end. I have explained you, just I have revised and introduced some of the new things to make you understand with full content coverage. And I also advise you to read the chapter, to read the topic thoroughly from the textbook, so that when questions will come, I will tell you how you can write the answers to get good marks. Thank you. God bless you.